Hello. Uh, so what we are going to look at is the grinding operation. We'll start with the basics of this particular process or the operation, that is the grinding operation. And so when we are talking about the basics, why are we doing that? That is basically to understand some of the basic machining concepts which we would be using or applying for the grinding operation. We'll be applying them to understand this particular grinding operation. So, starting with the basics, we will be introducing two major things or two major terminologies, that is the surface finish and the other one is the MRR. Now, when I'm talking about the surface finish or MRR, they are somewhere down the line connected to each other, and so we'll see firstly what is this, how we define surface finish, and what is the effect of surface finish on MRR, and likewise for or vice versa for the two. So let's start with what do you mean by surface finish, and how do we identify or how do we measure this particular quantity or value. So what we can see in this particular figure is, I have one object, let us say object 1, or let me call it as object A. Fine. And so when I'm talking about an object A, I will take an example and we'll see. So for this particular object A that I'm talking about, let us say this is an object A or a material A, and for this particular material what I'll be doing is, under a very high magnification, I'll be observing the surface of this particular object A. So how do I observe that, or what is the thing that I am observing? Let us take an example with the help of a small dot here. So as I'm magnifying the surface, what I'll be able to look at is a very small area or a region which I'm observing. So let us assume that this is a small dot, or this is the small area which I am observing under magnification. So when I'm observing it under magnification, what I'll be able to see is that this particular surface that I've observed here, that is the small dot that I've observed, is not a flat surface, but it is an uneven surface like this, having some peaks and valleys. So what I'll do is, like, if I want to find out the surface finish of the material, how do I do that? I need to take the measurement of these peaks and valleys, or different orientations of the surface with respect to some reference. So I draw a line which I call it as a datum or a reference, and with respect to this datum, I'll be measuring the values for the peaks and the valleys for this particular surface that I have observed here, that is this very small region that I have observed under magnification. So then what I would find is, the lowest or the closest point with respect to the datum is this one, which I am naming it as A, and its corresponding distance from the reference I am calling it as h1. Alright. Similarly, the farthest point for this particular surface that has been observed under magnification, or this small dot that is observed under magnification, for that the farthest point that I have observed is B with respect to the datum or the reference, and its distance I'm naming it, or I'm calling it as h2. So now this h1 minus h2, the difference that I am getting, I'll call it as RT, just a notation. Following the standards as per various reference books, but you can call it anything. All right. So this is nothing but the difference between the closest point with respect to the datum and the farthest point with respect to the datum. Now, if you could observe what I've measured here is, I have not considered the intermediate peaks and valleys, but the extremities, that is the closest and the farthest. That is for this whole surface, but I have not measured it everywhere, only with respect to a point here. This is the point that I have observed under magnification, and that whatever I have observed, the profile has been plotted here. Alright. So h1 minus h2 would give me RT. Again, I'm only going for the magnitudes. So either you do it h1 minus h2 or h2 minus h1. As I'm only going for the magnitudes, the negative or the positive sign does not matter. What I'm trying to say is, like, h1 is lesser here than h2, so h1 minus h2 if I'm going for, then this rt value would be negative. So if I want its value to be positive, I do it as I subtract h2 minus h1, but it does not matter to me because I'm not interested in the magnitude right now. All right, so what I've done is, for this particular point I've taken the extremities, and that is giving me the value of RT. This RT is nothing but the, I call it as the roughness of the surface, but it's an average roughness. Why average? Because I have not taken all the intermediate points, but for a small region under observation, this one, now only taken the extremities. That is why this would give me an idea about the average roughness of the surface. All right, so I can measure this for various points. This is point 1 point. I can take any other point somewhere here, maybe somewhere here, maybe somewhere here, somewhere here, likewise. So I'll get different values of RT, and these different values of RT, if I average it to the number of observations that I have taken, then it would give me an overall average roughness of the whole surface. All right, so this is one of the object that I have measured, this is one of the object that I have taken under consideration. If I take another object, let us say object B, and I'd follow the same procedure for this particular point, and then for this particular point what I get is, I get again some closest point is a1 dash, or a dash rather, the farthest point is b dash. Corresponding to those points, the distance from the datum or the reference is h1 dash and h2 dash, and so the difference or the roughness that I get is rt dash, which is shown here. All right, now let us take small assumption just to understand this concept. So now here, let us assume that for, or we can make it out from these figures as well. So what we can see is, like, this rt value that we have got, rt dash and rt here, for these values rt dash and rt, let us from the figure itself we can make out that these distances, the h1 dash and h2 dash, are smaller than these distances. We are assuming that, so which means that this rt dash is lesser than the rt value. So if that is what is happening, I can write it as rt dash is less than rt, which means that this surface number 2, or as I'd called the previous surface A, I'll call this as, let us say, B. Fine, because we are considering a B object. All right, so this surface number 2, which now becomes, let us say, which I'm calling it as surface B. The surface B is less rough than A. How did I get that? This RT dash value is lesser than RT value, which means that RT dash is less than RT, so B, that is this surface, is less rough than the surface. All right, now this is how do we go for surface finish or surface roughness, as you can call it. Now the important thing is something which is coming up now. So what we can do is, we try to relate these things, this concept, with the MRR. Why am I discussing MRR? Because we'll be coming to grinding or understanding grinding with respect to MRR. Right, so now what we can see is, like, as I have already differentiated how I can go for a better surface into less roughness or higher roughness concept, let us discuss the MRR. All right, so now what I get here is, let us say, again I would not put this as 1, but as we have taken as A and B, I'll put it as A and B. So this is object A. For this object A, what I could find under the magnification is something like this kind of surface finish. Similarly, for some object B, what I could find is something like this kind of a surface finish. Now what we can see is that the lowest point when I'm measuring with respect to the normal surface here, this gap that I'm talking about is much higher than this gap, which means that the material removal rate, that is the MRR, is more here and less here. So like why are we discussing MRR here? What is the significance of the material removal rate? So if you could recall in the earlier concepts that we had seen for the machining, uh, higher the MRR, poorer is the surface finish, and lower the MRR, better is the surface finish. Means that when I'm going for the grinding operation, what is my basic requirement is generally this grinding operation is surface finish kind of an operation wherein I'm removing very small amount of material. So when I'm going for a very small amount of material, what I'm required to do is like I should have a lesser MRR. That would essentially give me a better surface finish. And generally, like if we talk about the rods, if we are talking about, let us say, so that shiny part on the rod, we get it because of the grinding process. And so when I'm going for grinding, as I had already quoted, it is a kind of a finishing operation wherein my MRR that I am getting is lower, which means that the surface finish that I am getting is better. Alright, so that is what is the significance of the surface finish with respect to the MRR. Alright, now as we have already seen, now let us try to understand the grinding process in detail. So as we just discussed, grinding is a kind of a finishing operation. So what you can see from this particular figure is I have a grinding wheel. What is it, how is it made up of, we'll come to that. So what I have is I have a grinding wheel. Now I can also call it as a tool because that is basically used to remove the material from the workpiece. And now is this grinding wheel, it is shown in the figure that is rotating in the clockwise direction. So like if I bring some workpiece in contact with the grinding wheel, then what I may get is that if there is a relative motion of this surface of the workpiece and the surface of the grinding wheel, basically there would be a relative velocity, and the relative velocity would result into the material removal from the workpiece. I am not denying that there would not be any material removal from the grinding wheel, but that is something that we'll be discussing a bit later. So what I'm interested in is to machine the workpiece. So like when there is a relative motion between one surface with respect to another, there is some material removal or the wearing of the surfaces, and that is the principle by which we remove the material from the workpiece using the grinding wheel or a grinding tool. All right, so now we understand this process in a bit more detail. Before that, for that I need to introduce something what for the grinding wheel itself. So what I'll do is I take a very small sector of the grinding wheel, and I'm reproducing that particular small sector here like this. Fine. Now when I'm only focusing on this much of area, I'll also see what are the different particles available on the surface. So what I've shown is these particles, the 1, the 2, the 3, these particles are nothing but they are the abrasive particles. All right, now abrasive particles like emery paper is an abrasive material, so it has some abrasive particle in the form of glass particles on it. So these are not glass particles, but these are like you can consider it as good as the emery paper. All right, so these are the abrasive particles. There are different type of abrasive particles, we'll be coming to that a bit later. So like let us say that some X type of abrasive particles are used to make up this grinding wheel, and so those particles are 1, 2 and 3. Obviously I have taken a small sector, they would be, this whole wheel would be comprised of these many particles. And so what I've also shown is like grinding wheel is rotating in clockwise direction, so I've shown a clockwise direction of rotation here. Now what I'm focusing more here is like, and you can see that this particle number 1 is having different shape, 2 is having different shape, 3 is having different shape. So basically like something, when we are discussing the shape of these particles, it is something which we are not fixing. It may be these particles may be having any random shape, and it may be oriented in any random manner as well. All right. So these particles that we are talking about, the first and foremost thing that we are considering is it may have any shape, and its orientation is also random, which is something which is not in our hands when we are manufacturing the grinding wheel. How is it manufactured? What are the components which come into manufacturing of this? We'll be coming on to that. Fine. So now let us talk about the first particle, and then that is how we'll try to understand the operation. So this particular particle, like as the wheel is rotating in clockwise direction, uh, I'll also put this with this dotted line. What you can see is the surface of the workpiece. This small sector, I've shown it with the dotted line here. All right. So what do I have is, when the grinding wheel is rotating, this particle at some point of time comes in contact with a fresh workpiece surface, and so the workpiece is basically, like, let us say if it is not rotating, I'm considering it as fixed as at this point of time, and the workpiece would be rotating in this direction, let us say. Or if it is not rotating, if it is fixed, for example, what I'm focusing on is the force. So I'm not considering the rotation of the workpiece and anything as of now. So what is happening is, this is the work dotted line of the workpiece. The grinding wheel is rotating in this direction, so a force would be exerted upon this the particle, the abrasive particle 1, in this direction. All right. Now when this wheel, as the wheel is already rotating, at the next instant of time, this particle number 2 would come into this position, and it would come into the fresh workpiece, in contact with the fresh workpiece surface. But you can see that as the force is acting in this direction, which is obvious, when I'm talking about this particle number 2, this surface of this particle would be parallel to the force which is acting here, which means that there would be a force acting along this surface of the particle, not normal to it, like what is happening here, which means that there would be some rubbing action coming into picture here. Fine. Which is shown by this. All right. So when there is a rubbing action which is coming into picture, what basically may happen is, like, for this particular particle, it would remove some chunk of the workpiece material, but when this particle comes into contact, as there is rubbing, it would not be efficiently able to remove the workpiece material. All right. So this brings me to one conclusion, that as the particles are having various different shapes, and as they are oriented differently, I may not say that my cutting or the machining process that is happening is 100% efficient. Fine. So there is no 100% efficiency in this process during the grinding process. All right. So now when this thing is happening, like, obviously when the force is acting on this particle, the question may arise, then is it not that these particles may get removed because of the force which is acting? Yes, it does happens, but what is that thing we'll be introducing in the next lecture. But here what I will be introducing something else is, like, when this particle is there, this particle is there, all these particles in between them, they cannot be held just in the air, right? So, like, there must be some binding force, or there must be some binding material, and for that it must be bonded. So we use a binder which would be binding these particles here. So between these particles there is a binding material. We'll be introducing that binding material a bit later as we proceed with the course. So till now, whatever we have discussed, what we can conclude from the discussion is, like, these abrasive particles are not having a fixed shape, and their orientation is also not fixed. But then again, so if that is what is happening, then for our analysis, what we need to do is, we need to at least decide some approximate shape of these particles. All right. And so that is what we'll be looking at in the next slide, or the next page. But when I'm talking about a shape of this particular abrasive particle, uh, you must keep in mind that this is a two-dimensional figure. the shape goes into the plane of the paper also. So this particular shape which is going into the plane of the paper, something like this, into the plane of the paper, this particular shape is responsible for the material removal. All right, not the length by which it is going into the plane of the paper, but this cross sectional shape. I hope you are able to understand this. If not, then don't worry much about it, because it's not going to be that much important at this level. So this particular grinding material, or this particular abrasive particles, having the shape of whatever shape is shown here, this shape would be responsible for the material removal, and not the one which is going into the plane of the paper. All right, so with this knowledge, what we'll do is we'll take the next page and we'll see what are the approximations that we are considering for the shape. So what we can see is uh, uh, don't consider this figure. What we can say is, like, if we assume a particle to be a cubic, so all these three dimensions are the same. As we just saw in the previous figure, this length, this direction which is going into the plane of the paper, does not play a role in the type of the shape of the material which is removed. All right, so I'm not interested in this particular direction. So I may have a cubic shape or a rectangular shape, where a, b are the two different dimensions. This third dimension may be c, maybe a, maybe b. It does not matter to me. All right, because as we saw in the previous figure, this is the cross section that I'm interested, and the edge would be this one. So I'm only focusing on this particular face or this particular dimension. All right, so assuming that the approximate shapes of these abrasive particles are cubic or rectangular, based on this assumption, if you could recall your concepts of EG, then a view from this, if you view this particular particle from here, and if you could consider a small part of this particular particle which is performing the machining operation, this much portion, then the shape of the chip that you may get would be approximately triangular. Approximately triangular, I'm not saying exactly triangular. All right, so this is something, if you understand, it's okay. If you do not understand, then also it's not much of an issue at this point of time. All right, so now, assuming either the cubic shape or the rectangular shape of the abrasive particles, we move forward and considering what is basically happening during this process. So now, when this particular machining is happening, or when the grinding operation is taking place, what would happen is, as we had seen earlier, the grinding wheel, like, again I'm reproducing the figure here. I'm only taking particle number 1, and let us also take particle number 2. This wheel is rotating always, and when this wheel is rotating, obviously I have a workpiece surface also coming here. This is my workpiece. So when the wheel is rotating continuously, this particle 1, after one full rotation, again it would come into contact with a fresh workpiece surface. So over a period of time, what may happen is the particle 1 is always going to come into fresh workpiece surface contact over a period of time, which means that as this edge is exposed to the workpiece surface, what may happen is, over a period of time, there may be a wearing of the abrasive particles also, and this edge may get blunted over a period of time. And so when it gets blunted, what may happen is, ultimately it may assume a shape similar to this. I'm not saying exactly like this, but similar to this, which I may also call as a blunt shape. Why blunt? Because as we had seen in the previous, on a previous page, this particle number 2 is only performing the rubbing action. It is not removing the material from the workpiece, which means that it is nothing but a blunt edge that we may have. So when this particle number 1 gets blunt, what happens? Obviously it is not going to perform the cutting operation, but rather it would result into the rubbing action that is taking place. All right, now I would like to divert a bit from this particular discussion just to link what we had seen previously with this particular process. So when I'm talking about the blunting, what is important is what happens to the force is what I want to discuss. So that brings me to what we had discussed for the um, single point cutting tool, and this is what is happening. Like, this is the workpiece, this is your single point cutting tool, and this angle which I have shown is the end relief or the end clearance angle. And if you could recall what we have already seen in our previous sessions, is that the end clearance angle or the end relief angle cannot be 0 or negative. Forget about the negative as of now, but we cannot be even 0. 0 end relief angle means this edge would be like this, which means that there would be rubbing taking place between the tool and the workpiece. And when the rubbing action takes place, what happens? The forces increases, and the forces increases means, like, it would not, this rubbing action would not contribute into material removal, but it would just increase the forces. So the similar thing may happen here also. When this blunting takes place, when this particular edge wears off, there would be rubbing action that is taking place, and because of the rubbing action, the forces on this particular particle or the abrasive would increase. And I'm not only taking an example of this particular abrasive number 1, but it may be a case for all the abrasives. This is what happens for all the abrasives. Fine. So as the rubbing action takes place here, as there is rubbing, it is not going to remove the material, but the forces exerted would be higher, and higher the forces, it may result into something to the abrasive particles. So that's something I'll be taking over from this particular topic, or I'll be taking over from this particular discussion in the next lecture, where I'll be taking this rubbing action, and then with the help of that, what I'll be doing is I'll be defining a few important terms, very very important terms, that is the self sharpening of the grinding wheel, the dressing, the truing of the grinding wheel. And these terminologies are very very important from any examination point of view. That is, you talk about the competitive examination, you talk about the university examination, anything. So uh, I'll be taking it over from this particular discussion in the next lecture. Thank you.